Alright, I figured I would go ahead and give you a little practice test again. This one here is sort of an A6/A8 because it's got some elements of electrical and engine performance. Of course, there are some of the elements of engine performance that seem like electrical whenever you're taking the test, but I'll go ahead and jump with these, and I like to typically start out with a starter question. Starter cranks for a while and then stops spinning the engine and whines. What might cause this? Bad brushes, bad solenoid, bad starter drive, or worn bushings. Now, let me pause for a second here to say I'm going to go ahead and do the answers to this one at the end. I did 2 different videos the last time I did one of these tests, but what happened was a lot of people just didn't even watch the first part. They went ahead and just jumped straight to the answer part of it. So I figured, well, I'm not going to waste everybody's time making, I had like half as many people that watched the test as went ahead and jumped and watched the answer. So I'll just put them both together in one video today. You're checking the charging system for low output. A voltage drop of 2.67 volts is measured between the generator output terminal and the battery positive terminal. One possibility is bad rectifier, bad stator, bad connection, or you need to keep checking. Now, generators and alternators are basically the same thing nowadays based on the J1930 regulation. That wasn't really a hard and fast rule as far as the J1930 regulation was concerned whenever it put all the terms together so that everybody would supposedly be using the same terms. But if you look at that list of terms, you'll find out that they call the alternator a generator, but the people that like Visteon that rebuild alternators and build them and all that, they will be really quick to tell you that they're not going to call it a generator, they're always going to call it an alternator. And so anyway, the long and the short of it is it doesn't really matter as long as you know what you're talking about. The older vehicles, the generators on them are so far behind us now, nobody's liable to get confused if you say generator. Turn on the ignition switch to start and you hear nothing happening. The dome light and the warning lights remain bright. You got dirty battery terminals, excessive starter draw, almost dead battery, or an open TR sensor. Alright. Engine ping during acceleration can be caused by low compression, carbon buildup on heads, retarded ignition timing, or a rich mixture. Alright, question 5. A voltage drop test of the charging circuit should be performed when? A, when the engine won't start, B, when current's flowing, C, when key is on with the engine off, or D, P2403 is retrieved. Alright, question 5. Question 6. A digital multimeter is set to the kilo ohm position. The specification for a component being measured is 500 to 1500 ohms. The DVOM is reading 0.826. The pickup coil is A shorted, B open, within specs, or overheated. A blown head gasket is suspected on a 5-year-old vehicle with an overheating problem. Which of these tests is most likely to confirm the head gasket? A, cylinder leakage testing, B, cooling system pressure rise, C, compression test running, or D, cooling system dye testing. Question 8. During diagnosis, cylinder 4 begins to misfire with the throttle slightly open. A few seconds after the misfire begins, the number 4 injector stops operating. This means what? The injector needs replacing, the PCM's protecting the CC, the number 4 cop coil is faulty, or the number 4 spark plug has overheated. Number 9. Question 9. A tech is testing a Ford cop coil by removing the coil, inverting the cop coil so that it can't fire to ground, and then starting the engine and watching the scope pattern. This technician is doing what? He's destroying the PCM, in need of some real training, doing exactly what he should be doing, probably going to be fired soon, or A, B, and D in that order. A cop coil is being replaced due to an intermittent misfire on that cylinder. The technician measures the resistance of the spark plug center electrode with a DVOM and finds 200 ohms of resistance. What does this mean? A, nothing, he's wasting his time. B, the cop coil isn't the problem. C, too much spark plug resistance. Or D, the spark plug should be replaced. Question 11. A 92 5-liter Mustang was running perfectly until it had a high lift, high duration cam installed and all the work was done. The engine runs very rich, which means it makes black smoke, at idle but runs perfectly at road speed. Based on the information given here, what do you believe is causing the black smoke? Question 12. When a vehicle is cruising at highway speed, low load, the engine ignition timing will be nearest to which of the numbers shown below? 50, 10, 24 degrees, or between 10 and 30? I also used my McGillicuddy's ProScan tablet that I came up with here for that. Question 13. Under a heavy load and at engine start, the ignition timing will be A, 20 degrees above base, B, always advanced, C, retarded to base setting, or D, 5 degrees after top dead center. An engine cranks but will not start. There's no spark and no fuel injector operation, but the fuel pump kicks on for 2 seconds at key on. What's the most likely cause of this no start? A, low fuel pressure. B, an open crank sensor circuit. C, TP sensor stuck at wide open throttle reading. Or D, a stuck open EGR valve. Question 15. A 2005 Chevy Silverado 5.3 liter has induction backfire and stumble on cold start, but runs fine after it warms up. Which of these is the least likely cause? A, it's filled with high octane gas. B, diesel is mixed with the gas. C, the engine coolant temperature is an issue. Or D, slightly restricted catalyst. Question 16. What's the most likely cause for these compression readings on an engine that is in time? Question 17. A 4-cylinder engine won't start, but spins over normally. There's good compression on all cylinders except 4. A cylinder leakage test shows no cylinder leakage on any cylinder. How is this even possible? Question 18. The firing order on a V6 engine is 142536. The number 1 cylinder is at top dead center on the compression stroke. You need the number 2 cylinder to be at top dead center on its compression stroke. The valve covers have not been removed. What do you need to do to put the number 2 cylinder on top dead center compression? Question 19. An engine misfires for about 30 seconds after a hot soak start, but then smooths out and runs fine. It does this every time. There is no smoke, but a P0302 code continues to set. Shutting the engine off while it's skipping, you pull the spark plugs and find number 2 smoking as you hold it in your hand. What does this typically mean? Question 20. A low mileage vehicle has a high CO reading using exhaust analyzer. This could be caused by A, an exhaust leak near the downstream O2 sensor, B, a bad in-tank pressure regulator, C, an open coil on a fuel injector, or D, unmetered airflow in the intake system. Alright, now we're going to do the answers. And I'm going to talk a little bit about each one of these just to kind of give you a little bit of an idea. And so let's jump into this and see how you did. And so here we go. Starter cranks for a while, then stops spinning. That's a bad starter drive. That's whenever you hear the starter going whoa, 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 and the engine doesn't start, because the starter drive basically has got an overrunning clutch in it, kind of like it's a rollerball clutch, like a roller clutch like you would see inside of a transmission. You know, a lot of people will call a one-way clutch in a transmission a sprag, but a sprag is a little bow tie shaped thing. Roller clutch does the same thing as a sprag, but the balls roll up little ramps and they got springs, you know, that keep them off the ramp. Off of the ramp, so they don't foul between the inner and the outer races. But that is very similar. You might notice a lawnmower has got a vaguely similar, except it uses little balls that roll around in there. I'm talking about a Briggs and Stratton lawnmower. There's a whole bunch of different small engine one-way clutches for the pull cord right now. But this is a bad starter drive, and that's kind of what it looks like. I borrowed that illustration from Pearson, by the way. You're checking the charging system for low output. A voltage drop of 2.67 volts is measured. That's a bad connection. That's too much voltage drop. If you've got 2.67 volts that you're dropping between the positive battery terminal and the alternator, there's a lot of places that goes on some vehicles, but you shouldn't be dropping 2.67 volts between the alternator positive terminal and the positive battery terminal, because if you are, you got some issues. You got to find out where that bad connection is, and typically you can move your test points closer together and zero in on it. You can also do a voltage drop test if you've got headlights. Like if you've got one headlight that's dim and the other one's bright, and you want to find out if it's some kind of a problem with the voltage drop in the ground or the positive circuit, you can actually, if you can get to it, sometimes on modern cars it's really hard to get to the plug to the headlights, but if you can get into that headlight assembly, back probe the connector or whatever, however you want to do it, or use your little prick tool, and you can get in there real close to the headlight, and let's say you got your dim headlight, the one that's illuminated, because there's three wires, one of them will be bright and the other one will be dim typically, if the same bulb is doing both bright and dim. You hook into that with one side of your meter, and you take your other part of your meter, set it to volts, and go to the positive battery terminal. You are measuring voltage drop across that entire circuit, all the way from the positive battery terminal all the way through the whole harness, the switch, and everything to that bulb. You can compare that to the one that you do it normally, and if you see voltage drop between the positive battery terminal and that dim light bulb, then you've basically isolated an issue. Now, if you don't see any voltage drop on the positive side, you can go to the negative side of the battery and then go to the ground wire at the bulb. Now, that's not going to check a bad connection where the connector is plugged into the bulb. Sometimes it'll melt and scorch and all that. You're not going to find that by doing this voltage drop test, because it's really difficult to, of course, if you've got that problem, you can unplug it and look at it. Or sometimes you'll see that the wires have discolored and scorched a little bit because the current flow has oxidized the terminals and current has slowed down, and it basically creates heat and it melts things and all that kind of thing. That's fairly common. I used to keep a little clamshell box of headlight bulb pigtails that I bought up there at Advanced Auto Parts in my office, and whenever we ran into one like that, we would replace that pigtail. And something else I always like to do to kind of to keep oxygen away from those terminals where the current was flowing, this was just my personal preference, was I would take that dielectric grease, like that WA10 Motorcraft stuff, whatever the part number is now. I think they've changed it, and they use it for brake caliper slide grease and all that. But that silicone dielectric grease does a good job of keeping oxygen away from those terminals, and it kind of prevents that kind of thing from happening. Not that it's a terrible problem on every bulb, but if it does, just as a belt and suspenders measure, I like to put some of that on there. They also make some stuff that's real expensive that you can put on terminals that helps current flow better, called Stabilant 22. You might want to look that up. You can buy it on Amazon, but it's really high. But you put it on the terminal, it helps it. It almost makes it as solid as a solder joint, Anyway, this is what you might see that you could visually tell there's a problem. There's obviously going to be some voltage drop between that terminal and that wire. And see that heat and how it's blistered and everything? That was on a trailer vehicle that I had over there. Alright, you turn on the ignition switch to start, you hear nothing happening. The dome light and the warning lights remain bright. One possibility is an open transmission range sensor. Either that or one, an open one. Sometimes I would tell people, if they say, I don't have any start, like if you try to start it and you hear a little and then the lights go dim, that's a bad connection somewhere typically. But if you don't see the lights go dim, and if these lights stay on really bright, it's not going to be excessive starter draw, and it's not going to be an almost dead battery, because that will also cause these lights to dim. If these stay bright and nothing happens, there's not anything even making it to the starter typically. Transmission range sensor could be your trouble. And that's basically the way it's, this one right here, I just threw one up there for my 06 Explorer. And if that thing, I have had people, whenever they were talking about, like when I was teaching, I'd say, hey, it won't start. And I'd say, put it in neutral and see if it starts there, because you're testing that contact. Because sometimes the contact's in the switch, this one will be worn out, or maybe it's out of adjustment or something, and that one's like that. If I suspect that it's out of adjustment, I'll have somebody put it in reverse and see if the backup lights are on. Or you can look at your scan tool screen and see what it's reading whenever you drop it in each gear and all that. Alright, engine ping during acceleration can be caused by carbon buildup on heads. Now, quite interestingly, there's technical service bulletins that talk about carbon buildup issues using premium fuel, like higher octane fuel, in vehicles that are made to run 87 octane. And it leaves some of the fuel in there. It doesn't burn it all because it burns a little bit slower. It leaves some of it in there to coat the heads, and the piston head can actually build up carbon and begin to cause a pinging problem because of the carbon building up on that. And it's just pretty interesting how that kind of thing can happen when people are add the premium fuel so that it won't ping. Then they're actually creating more of a problem, so that all they'll be able to ever use is premium fuel, unless somebody uses some type F transmission fluid and whatnot to clean the pistons and the heads and all that. That's a tricky thing that you don't need to do unless you really know what you're doing, but we used to do that. We pour transmission fluid in there with the engine running on a good hot engine, soften the carbon really, really good, and smoke the whole parking lot up. We always did it outside. Then follow up with some cold water, trickling it in there, and that would basically clean those pistons enough so that a lot of the time, the engine would stop knocking. Sometimes it'd come in with a knock that sounded like a real serious knock, and all it would be was carbon buildup on the pistons. I had pistons in the head, and I had this one guy that said him and his buddies all had older model Ford pickups that they drove. It was in some kind of an old Ford pickup club or something that they had, and he said all of them were experiencing this pinging, and if they retarded the timing, they would have issues with power and fuel economy. Of course, old V8 Ford pickup, you're not going to get good fuel economy anyway, usually. But I mean, I'm talking about these were 70s pickups with carburetors on them and stuff like that. But I told the guy, I sent him an email back, and I said, what you need to do is, pour some type F transmission fluid. I always say type F because if somebody does this on a engine that's got an oxygen sensor on it, that type F transmission fluid will actually coat. I mean, it doesn't have silicone in it like some of the other transmission fluid does and these other additives. The old type F is just plain old transmission fluid, straight transmission fluid without silicone, because anything that's got silicone in it will coat the ceramic zirconia bulb on the oxygen sensor and render it ineffective. So if you're going to do that on any car, if you feel like you've got carbon buildup on the heads and the piston, don't use anything but type F. Now they make some other decarboning compounds you can use, but you start out with the type F transmission fluid to soften the carbon, and then you follow up with the water. Believe it or not, back before there were catalytic converters, some of the older mechanics used to pour rice down there to clean carbon off. And it was funny because if you poured that stuff down there, you'd smell that rice cooking, and you'd see puffed rice. It looked like you were making cereal coming out of the exhaust. Sometimes whenever there were some rings that weren't seated for whatever reason on an engine that had been rebuilt that didn't have enough glaze breaking done on cylinder walls, they'd try to get the ring seat by pouring a little Dutch cleanser down the carburetor while it was going in. There's all kinds of crazy stuff that the older mechanics used to do. Of course, I'm an older mechanic and I did some of that stuff too. But anyway, a voltage drop test of the charging circuit should be performed when current is flowing. If you cannot do a voltage drop test, and I should have mentioned this earlier, on anything unless current is flowing. If you're wanting to do a voltage drop test and current's not flowing, you're not going to get any readings anyway. So you got to have current flowing. On a charging system, that means you got to have the engine running, you got to have the alternator putting out while you're doing the test. And I probably should have put this question right after the other one. A digital multimeter set to the kilo ohm position. Whenever you're set to the kilo ohm position, this right here is 1,000 ohms, right? If it's 0.826, that's 826 ohms. So this is within specs if it's 500 to 1,500. So always pay attention when you're using a digital voltometer, if you're one of the new guys, to what this is. If it's it's meg. If it's just ohms, it's basically reading straight ohms. If it's kilo ohms, that's going to be 1,000. So this is 826 ohms that way. Blown head gas is suspected on a 5-year-old vehicle. What I used to do, and what I learned when I was working at a filling station in the in the 1970s, you know, whenever I was working at that Gulf station over here in this little town nearby where I grew up, was that if you feel like you have a blown head gasket because of an overheating issue, you can crank it up cold and let it run for about 60 to 90 seconds. Switch it off, take the radiator cap off, and if it builds pressure in 60 to 90 seconds after starting it, then that thing is pushing compression into the coolant. It should not build on a cold engine. This has got to be a cold engine that's been sitting there for several hours. It should not build pressure in the cooling system that quick. Some of the guys would like to take like a balloon or whatever, or maybe a rubber glove, and stretch it over and tie it to the radiator fill neck with the cap removed, and start it up with that on there and see if it inflates that glove or that balloon. And that works pretty darn good. Anyway, I just thought I'd mention that because that's a pretty good little test. The best thing about a test like that is it gives you some pretty solid results, and doesn't cost much of anything to do it. So just think about that if you have the idea that, see, there's so many different ways head gaskets can blow. You know, they can leak coolant one way or another, either into the combustion chamber, out of the combustion chamber. In other words, pressure from the combustion chamber can go into the coolant, or it can leak coolant out from under the cylinder head. And there's all kinds of stuff. Or you know, it can blow between cylinders, which we'll talk about that in a minute. During diagnostics, cylinder 4 begins to misfire with the throttle slightly open. A few seconds after the misfire begins, the number 4 injector stops operating. The PCM is protecting the catalytic converter. Now, the reason I said that, the first time I ran into this situation where I saw a vehicle, and I've mentioned it on here before, it was on one of those 3.8 liter Ford Windstar engines that has all the little EGR ports, and when I would crack the throttle just a little and EGR started to flow, the one that wasn't clogged, the little port that wasn't clogged, was feeding all of the doggone EGR into that one, and it would start skipping. And then I noticed that while it was doing this skipping, the injector had stopped operating, and I was thinking, aha, we got an injector problem. Well, that's not necessarily the case, because it'll shut the injector down to stop putting gas in there to save the catalytic converter. If it starts skipping, though, at exactly the moment the injector shuts down, you may have an injector problem. I worked on a Jeep Cherokee one time that still had the old Bendix fuel injection processor on it, or the Bendix fuel system, and that's one of the ones that was made between 87 and 1991, and those right there would do, or 87 and 90, it was 3 or 4 years ago they made it. It was a strange system. It was a Renault sort of a deal, but one way or another, that thing, I've had one that would start misfiring, and it would stop sending a signal to the injector, whatever one it was, injector 5 or 4 or whatever it was. And I was thinking, well, that's weird, and I would notice that it would go dark coming out of the engine controller. And so I would switch it off and I'd let it sit there a while, and then I would start it up again, and it would be firing on that cylinder, and it would run a little bit, and then it would stop firing that injector again. Well, the end of that story was, after I had a bunch of those engine controllers because of the reason I told you about in a previous video, that they had a recall or a program, so they were going to replace a lot of the engine controllers on those things because of a cold start issue. But they didn't want the old ones back, so I had me a whole library full of them doggone engine controllers from Jeep Cherokees for a while. Anyway, whenever I plugged in another engine controller, it did exactly the same thing. And I said, well, that's interesting. And so that's when I got to checking the, if I'd have been using a scope, I could have found it by doing a, current ramping on the injector. But I just unplugged the injector because it was real easy to get to, measured the resistance of it. It's supposed to have 16 ohms on that one. It only had 3 ohms on there. So that injector had a really low resistance because the windings were partially shorted, but it would heat the driver up inside that engine controller, and the driver would shut down. And you'd think that should basically destroy the driver, but that old Bendix thing was tough as nails, and it would basically just cool off and come back online. Typically an injector with 16 ohms ought to pull about 0.8 amps or something like that, and those injector driver transistors in there are typically, if it's sequential, are typically capable of handling 3 or 4 amps, at least on GM cars. That's what a GM engineer told me, that those drivers can handle 3 or 4 amps. And so 0.8 of an amp is what an injector typically pulls ordinarily, Anyway, a tech is testing a Ford cop coil. This guy's doing exactly what he should be doing according to Ford. Now, Ford's procedures on later model cars may not be like this anymore, but they have a little plate that you put on top of the coil. You hook your scope up to it, and you take the coil. It just flies in the face of everything you know about coils to let a coil fire when it's got nothing to fire to, because that sounds like a destructive thing to do. But Ford had us doing this. They'd say, turn the thing upside down where there's nothing it can fire to whatsoever, and fire it up and look at this pattern. And it had a crazy screwy pattern like nothing you've ever seen. They told you it should look like this if it looks like anything. And I have pictures of those patterns I absolutely could not find. I don't know how many pictures I got in all the different computers I've got, but I dug and hunted and poked around, and I could not find that picture anywhere. And I feel like a dummy because I should post it here. But anyway, if you could actually do that and build your own little waveform library about this. But that is a Ford procedure that they came out with, and then they came out with it, I think, in like 2002 for testing those coils, stress testing the coils, they called it. But anyway, you might think this guy's a buffoon for doing that, A cop coil is being replaced due to an intermittent misfire. The spark plug should be replaced. I ran into that, and I've told this story before, but I started measuring the center electrodes on spark plugs a long time before I heard of anybody else doing it. And so I would, just for the fun of it, you have to scratch that electrode pretty good with your meter. I like to put it in a vise, and I like to scratch the place where the wire plugs on. And the center electrode, which is the one that runs down the middle of the plug, I'd scratch into that, and I'd look, and I would compare all of the spark plug resistances. And I actually wrote a Motor Age article, and I think I may have shown a picture on one of my slideshows of one I tested that had 200 ohm resistance. They're supposed to have this actually, and by the way, after I started doing that, I found this illustration on a piece of Ford training software, and I actually put 200 ohms on that meter, but it has like 8,000 ohms per plug as a spec. Well, that's not really a solid spec. What I like to do is look and compare all of the plugs to see if they're close to one another. And what I usually find, if I'm measuring all the plugs that I pull out of one with plain old plugs or whatever, is I'll measure from 3 to 7,000 ohms per spark plug, and they're all really close to one another. And I had mentioned this in a Motor Age article, and this champion spark plug engineer sent me a nasty email, and he says, that's stupid, that's wrong, you shouldn't be measuring resistance of spark plugs because that's just not the right way to do it. You ought to use a scope, blah, 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 blah. And so basically, this right here is what I found in the Ford training. Well, just because I wanted to see where this guy was coming from, I got a brand new set of champion spark plugs that we had bought to put in a Dodge or a Chrysler or something, because I like to go back with OEM, and Champion came in Dodges for a long time. And I'd put those Champion spark plugs in the vise, And the resistance measurements on those Champion spark plugs, brand new, right out of the box set of Champion plugs, measured from 2,000 to 17,000 ohms and everywhere in between. And that's just totally an anomaly. If you get Autolite or Motorcraft or AC Delco, any of the other plugs, NGK, if you measure all of the spark plugs, they'll all be pretty close together. But on those Champions, they were everywhere, and that was just very interesting to me. The Champion spark plug guy was trying to give me a hard time for measuring the center electrode gap on spark plug. 92 5-liter Mustang was running perfectly till they had a high lift, high duration cam installed, and the work was run properly. It was running rich and idle, but it was running good at road speed. The map sensor, remember, this is before the mass airflow. This it's a 92. Well, I say that. I said 92. I probably dropped the ball on that year model because, come to think of it, Mustang came out with mass airflow in 1989. So slap my hand for that. 92 had mass airflow because they didn't have what was always confusing about Mustangs is Mustangs didn't get data stream function until 94, but they did get mass airflow in 89. So I sincerely apologize for saying 92 because I shouldn't have said 92 because 92 had mass airflow. Now the reason I'm going about this, there was a guy that was having this old Bronco, like it was a 73 Bronco, redone and restored and all that, and he put a Mustang engine in it. It was like a 86 or 88 Mustang engine or something like that, you know, the 5-liter. And he had the engine cammed up when it was built, and it would idle really rough and puff out black smoke, but whenever you got it above idle, it ran okay. And the reason for that was because of the fact that it had an aggressive cam. It had low vacuum at idle, and low vacuum at idle was interpreted by the map sensor, which is what that one was equipped with, as a high engine load. And so what we did on that was we bought a mass airflow kit, which came with an engine controller, a wire harness that you could, put some, if you had to hook this mass airflow sensor up to the right pins on the engine controller. They sent you, of course, you're using the original harness, but they used some, pins that were vacant on the existing harness, whatever. And that was a pretty cool little setup. I think it cost $400 or $500. It wasn't cheap, but on the wall, there was a little controller thing, adjustment deal. They had little numbers on it, and you could actually, put little screws in it and put it over close to the airflow sensor, and you could use a screwdriver to adjust and fine-tune that mass airflow reading. That was, it was the reading coming from the mass airflow sensor was going through that thing on the way to the engine controller, and you could fine-tune it to where it was almost like adjusting a carburetor. It was real smooth, but I thought that was pretty cool. Now see, that Mustang engine had fuel injection on it, but it was required on a map sensor, and a map sensor gets really confused if you try to cam one up because of the fact that it is expecting a certain level of engine vacuum, whenever you're idling and all that. And, anyway, when a vehicle is cruising at highway speed, low load, the engine ignition timing will be nearest to 50 degrees. If you look at that, if you're looking at the ignition timing on a scan tool, when you're driving in overdrive 45, 50 miles an hour, your highest gear, and you're holding steady throttle on a flat road, you're going to see this thing floating up around 50 to 55 degrees. Now, one of the reasons that I got into that was on these Jeep Cherokees and some of these other ones that you're doing cam. You're actually the cam sensor is in the distributor. It doesn't have what you'd call a pickup coil in the distributor because it's got basically a cam sensor in there, and it's got a crank sensor to give it its ignition pickup signal. And so anyway, if you have that rotor alignment wrong, and the first time I ran into this was back in 1984. I was working on like an 82 or an 83 model Lincoln, and those are the ones that have nothing in the distributor except a rotor, and they had a map sensor, and they also had a crank sensor, but they did not have any kind of a cam sensor. And so what we would have to do was there was special tools you had to use to line up the distributor exactly right, because and when that timing gets up around 50-55 degrees, if the rotor alignment's not right, that spark will jump from the tip of the rotor to the wrong post because it's advancing too much. It needs to have a window where it's firing right on this post, and that window's not going to change. And if you're at 50 degrees and it's closer to the post behind it than it is the post where it is, then it's going to cause it to surge and everything. And so that's one of the reasons that I got to look into that. And we ran into some issues where I had to set some Jeep 4 liters up, and I'm talking about the ones that had a distributor and the cam sensor in the distributor. You could get the rotor alignment off of one of those too. And so that was the point there that we were doing that. We'll talk a little bit more about that later. All right. Under heavy load and at engine start, ignition timing is going to retard to the base setting. Now that's an interesting thing too. Back when I was driving my 74 F-150 and I was experimenting a lot with electronic ignition, that 74 F-150, I basically converted it. If I remember right, that one came with points. And I converted it to electronic ignition because I just wanted to have electronic ignition on it. I was really fond of electronic ignition. I didn't like points. I mean, I worked on vehicles with points ever since 1972 or 71 or whatever it was. But anyhow, the point is, I says, well, I've got some parts here. I've got an ignition module for a Chrysler, which is one of those old 72, 73, them old potted modules they used on Chrysler electronic ignition. And I've got a Ford distributor here because I had bought this engine from this guy that had a electronic ignition in it. It was a 76 model, I think. And I dropped that distributor in my pickup truck and I wired it up to that Chrysler module. Now the Chrysler reluctor in a Chrysler distributor's got real sharp points on its little reluctor teeth, and on the Ford they're kind of fat. And so I could get this thing to run, but what I would have to do in order to get it to start was I'd have to retard the timing by hand. Once it started, I could advance the timing by hand, and that Ford would run really good with that pickup coil from that Ford distributor firing the coil using that Chrysler module. It was a little experiment I did just to see if it would work. It wasn't practical because I wasn't going to get out of the truck and retard the timing every time I started it. Now I kind of knew that because I remembered on the old Model Ts, and I'm not that old, but I do know on the Model T and the old Fords, on the steering wheel you had a lever to retard the timing before you started, and anybody that didn't retard the timing would get kicked back when they was trying to turn the crank and fire, and if it kicked back on you when you didn't have the timing retarded, you would break your arm. So whenever you have these engines nowadays, they're going to retard the timing when they're starting it for easier starting, and then advance the timing after it starts up. That's just typically the way that's been working for a very long time on the ones that have computer controlled timing. Now I ran into a problem on a Bronco one time, back when I had the SBDS machine in my service bay, and that stupid thing would not start worth a flip unless you unplug the spark output connector. You pull the spout connector like you would do if you were going to set the timing, that thing would fire right up. But if you put the spout connector back in it, you couldn't get it to start for love nor money. And whenever I ran the, I plugged the, that SBDS machine had a function that worked kind of like, it was like almost like it was an electronic breakout box. You'd plug it in between the harness and the engine controller, and then you could say, look at the stuff that it was going to paint on the screen for its traces. And I found a bad ground, a scratchy ground down there where the negative terminal from the battery connected to the engine block. The starter would spin just fine. That's what was amazing to me. I might have been able to find it doing voltage drop. But what I found was a crazy ground, scratchy ground when I was spinning it over. Clean that thing up, fix that whole problem. But anyway, it retards the timing. Now, I'm not here to explain exactly why that Bronco did that, but I did, I've learned a lot over the years about how important it is for the timing to be retarded while the engine is starting. All right, the engine cranks but won't start. That's typically going to be an open crank sensor circuit. Why? Well, if the throttle position sensor is stuck at wide open throttle, you won't have any injector operation because it'll be in clear flood on the ones that have clear flood, but it will still have spark. Okay, Low fuel pressure is not going to cause it to have no spark and no fuel injector open. A stuck open EGR valve is not going to do that. An open crank sensor circuit can affect spark and fuel injector operation. And the reason you know the engine controller is awake, and I've said this before, if you switch on the key and you hear the engine controller turn the fuel pump on for 2 seconds, you know the engine controller is awake and is able to think, but there's not any input coming from the crank sensor typically. Now, I had an engine bench that I got from Consulab when I was teaching mornings over at this local dual enrollment center. I set that thing up, brought it up from the ground up. And that engine bench had a 2010 Cobalt engine on it, and it had cam and crank sensors. And so I basically had a little box set up on that thing where I could go in there with a computer and I could set bugs that would come and go and all this kind of stuff. And there was a breakout box built right there on the engine bench. This thing cost something like $13,000, but it was really cool. And you could basically get your scope and look at all of the different, you have a scope. I had a scope set up over here where they could just basically plug into the, the banana plug terminals on the little built-in breakout box. But one of the things I noticed was while it was running, I could kill the crank sensor using my little computer thing. If you kill the crank sensor while that engine's running, it will keep running, which I thought was very interesting. But if you kill the crank sensor while it's running, the first time you switch it off and try to restart it, it won't restart. And so that kind of reminded me of this girl that came walking into the automotive department after all the students were gone one day, and she said, "Hey, my Trailblazer's sitting out here and I can't get it to start." And so I spun it over and it wouldn't start. And so I put the scan tool on there, and the computer was talking to the scan tool just fine. I spun it over. I didn't see no RPM signal. And on that Trailblazer, it was like a 04 model, I think, or something like that. It had this straight 6 in it. You can open the hood and you can look down there and see the crank sensor, if you're standing by the driver's side fender. And I just reached down there and unplugged it. You got to bend over. If you're short or got short arms, you're going to have trouble with it. But I bent over the fender, got it unplugged, ordered her a $16 crank sensor. They brought it from the parts store. She paid them for it, and I put it in there, boom, fired it up, and she went on her way. She thought I was Superman after that. That wasn't hard, though, because I noticed whenever I spun it over, there was no spark or anything. Didn't see an RPM signal. Hey, there you go, All right. 2005 Silverado 5.3 has induction backfire and stumble on cold start. Slightly resistant exhaust is the least likely cause. You're not going to have that. Now, you can have a problem like that because of the ECT, or because diesel is mixed with the gas, or because it's filled with high octane gas. Now, the reason I know that is I have actually seen all 3 of these right here. Now, I will tell you, if it's got an ECT sensor issue, it's got to be just exactly within the range of failure to cause that, but it can cause it. Filled with high octane gas. I had a guy that was working with it named Mark, and he was over there. I was basically sort of like his mentor, and I gave him marching instructions when he was out of ideas. And he had that Bronco that he was working on. It was nearly brand new at the time. This was like in 1993. And he'd crank that thing cold, and it would pop and snort and induction backfire and carry on. And this was that, high octane gas deal. He kept fooling with it, and he never could figure out what was wrong. And I says, go out there and ask the customer what kind of gas they put in it. And I said, I bet you they're going to tell you they got premium gas in it. And so he went out there, and they said they had 97 or 93 octane gas in it. And so I says, okay, what you need to do is you need to tell them to burn this gas out and put 87 octane in it, and that'll take care of their problem. He'd wasted a couple of hours trying to make that happen, and all it was they put gas in there. Okay, you might remember the 89 Taurus I was talking about that I got from the first time. We didn't even have any 89 Tauruses yet, but this rental car company sent one in there. And this thing right here, it was really, really hard to start when it was cold. And if you could feather the throttle and keep it alive until it warmed up, this thing would run like a spotted ape. I mean, I said this the other day, and somebody said I had to look up and see what a spotted ape was about. But the point is, it would really fly and it had high compression on all the cylinders, like, over 200 pounds on an engine that usually had 160 because it was just a 2-valve, and that was a Taurus 3-liter. But that guy, whoever took that rental car back, put diesel in it instead of gasoline. Now, he had to have done that on purpose, unless there was a pump somewhere that had the smaller nozzle that would let you, go through that little thing. Anyway, the long and the short of it was, all we had to do to fix after I fought it a while, and you'd see it'd smoke a little bit at idle, and it would ping a little bit when you were driving it down the road. But if you could ever keep it running, it ran better than a regular Taurus. It's kind of a funny story. I was telling this story to some of my students, and this one guy that was a kind of a knothead, he was always doing crazy stuff with his 06 Ranger, and he put a bunch of diesel in his Ranger to see if he could get it to run better. Well, you had to get the mix exactly right, All he did was cause himself a problem. And what was strange about that was about 2 or 3 days later, a guy was having almost exactly the same problem on another vehicle that he was working on. And I said, bring me some of the gas. And he brought me some of the gas, and I got it on my hand, and I waved it around in the air. And after I waved it around in the air for a little bit, until it had mostly dried off, I smelled it, and I smelled diesel. And that's how I kind of figured out that it had diesel in it. Plus, I hooked the injector cleaning machine up with some clean gas, and it fired up and ran normally. Anyway, so high octane gas can cause this. I'm not going to say it's going to cause it every time, but it can. Diesel mixed with the gas can cause it. Depending on how much diesel you got in there, that's a sliding scale ECT sensor issue. I also had a Dodge one time that the guy said he gassed it up, and he drove it about 2 blocks, and it quit on him. And we pumped the gas out of that darn thing, and I never really found out what was wrong with that gas. But he only put about, just a little bit of gas in it, apparently, because I pumped out like 5 or 6 gallons and the tank was completely empty. Sometimes I would like to just start the pump running and get a container and, pump the gas out until I could see if there was any water that was picked up by the pump that would go into my clean container. And on that one, there was no water. We did alcohol test on the gas. It didn't have a lot of alcohol. I put my hand in it, waved it around. I didn't smell any fuel. But when we put we put gas from a different source in that Dodge truck, it fired up and ran just like a brand new truck. That gas, something was wrong with it, but I have no idea what it was. Anyway, slightly restricted catalyst is not going to cause that, though. All right, this one right here is going to be a blown head gasket between cylinders 2 and 3. That's an easy one. Most of you guys probably got that one. A 4-cylinder engine won't start, but it spins over normally. Fellas, I have actually seen this, and you've probably heard me talk about it before if you've been on my channel very long. This guy brought us his little Honda CRX, and he had wrecked it, and it was the one that had a 1.6 in it, and it had the 88 model, and it had that little it had fuel injection on it, multi-point fuel injection on it. And so I said, okay, so you got multi-point fuel injection on this one. On the other one, it had throttle body injection. It was a 1.5. It came out of a car that wasn't a hot rod. It was a plain little old CRX. So we were going to take the 1.6 out of the crashed yellow 88 CRX. And this other car was an 88 CRX too. But I asked my guys, I said, oh, guys, look at here. We're going to do an engine swap from this car to that one. What do we need to do? Because they said, oh, we got to change the engine controller and all the harnesses. No, you're not going to do that. We're going to take the intake manifold and the exhaust. We're going to open them up. We're going to pull that motor out of that yellow CRX, and it's going to be a lung block. And we're going to drop it in here. But before we do that, they tell me this blue CRX has got a bad engine in it. And you can spin it over and you go, I said, well, it sounds fairly normal. I don't know, just spinning it over. And so we checked the compression. It had absolutely not a single ounce of compression on cylinder number 4. I said, now we're going to do a cylinder leakage test. I'm in teaching mode. And so we did a cylinder leakage test. Of course, you got to get the cylinders on TDC compression to do a cylinder leakage test with both valves closed. Anyway, this son of a gun had absolutely no cylinder leakage on cylinder number 4 at all. Had no compression on cylinder number 4 at all. And I'm sitting here trying to figure this out in my mind. I said, good grief, how is it even possible for it to have no compression and no cylinder leakage on that number 4 cylinder when it had pretty good compression on all the other ones, and it was spinning over just as free as a bird? Well, when we got the motor out it turned out that whoever was driving that little blue one had thrown a rod. When the rod came loose from the crankshaft, it was violent enough to where it knocked a hole in the back of the block, and the piece of the busted rod, it basically, the crankshaft broke the rod off right there, so there was only about this much of the rod still connected to the wrist pin and the piston was at the bottom of the cylinder, couldn't go any farther. And whenever you spun it over, the crankshaft would go past that busted rod. But see, there was not any air leaking out. The piston was not moving. That's why it had no compression. But it didn't have any cylinder leakage either, because the rings were still seated and the valves were closed. Anyway, that was one of those mysteries that I had to figure out, and whenever I would slap myself in the head and I say, there's only one way this can happen, really. Because you got to think, usually when one throws a rod, the engine don't just keep spinning over. Not usually, unless it knocks it out of there where it falls down in a pan. It can do that too, That would knock the hole in the block. Firing order on a V6 engine is 14236. That's 300. That's 120 degrees, between each firing event. So the number 2 cylinder needs to be at TDC on its compression stroke. So basically, you need to turn this thing 240 degrees. 120 degrees, if you're turning it the way it'll run, it'll put you at 4. Another 120 degrees will put you at 2. So 240 degrees will put you from there to there. And that's one of those old, for any engine like that, if you know the firing order, if it's a V6, it's going to have 120 degrees between firing events. If it's it's going to have 90. If it's a V8, it's going to have 180. How many does it have if it's a 5-cylinder? If you look at that, I think it's 145 degrees or 140 degrees or something like that. I figured that up one time. An engine misfires for about 30 seconds after a hot soak start, but then turns out smooth and runs fine. When you pull the plug out, you see steam coming off of it, coolant getting into the cylinder. That happened on, I don't know how many times I've seen that. There was a rash of that kind of thing going on these some of these 3.8 liter engines and some of these Windstars, and they would bring those things in there. And what we were supposed to do as a part of a program that we were doing was we were supposed to check the compression on these. Number 4, if I remember right, was always the one that was getting coolant in it for a while. They had some kind of an issue with that, and if we did a compression test and it came out okay, then we had supposedly satisfied that program. But I was telling the guy that was working with me, I said, this is stupid, because you're not going to find coolant getting in a cylinder by doing a compression test. So what you got to do is switch it off while it's still skipping and pull all the plugs out right quick, and you're going to see one of those spark plugs with steam rolling off of it, and you may even see some crusty light green deposits where coolant has cooked itself onto the plug. And that's one of the ways you can tell. You can also see that stuff on the piston when you pull the head off, if it's just been trickling. Now, if it's got a lot of coolant that's going into that cylinder, it may have that cylinder head, that piston head, so clean it looks like a brand new piston. That's what happens when there's a lot of coolant going in there. But if there's just a little bit of coolant going in there that only squeezes in there after a hot soak, when the coolant system builds up pressure and it pushes some in there, there you go. Those kind won't push compression into the water though and overheat it. They just cause a skip after a hot soak. My Jeep Cherokee was an '01 model, and it picked up a spell on cylinder number 3, which is fairly common on those darn things, where it was when I would drive all the way from where I worked, and I'd get to the 30 miles, and I'd pull in here at Winn-Dixie to get me some bananas, because I like bananas in my cereal. I would go back out there after buying my bananas, and when I cranked it up, it would skip on number 3, and I pulled the code. It would actually flash the check engine light too. And so whenever I did an inspection on it, when we pulled it off, you could see where the head gasket was blown. I meant to put that picture up here and show it to you, and I dropped the ball, which bothers me when I drop the ball, because the ball bounces away and I got to go chase it. A low mileage vehicle has a high CO reading using an exhaust analyzer. This could be caused by a bad in-tank fuel pressure regulator. CO basically means you've got a slightly rich mix.